So as she explained, the research that I conducted was regarding exploring entomopathogenic fungi and nematodes for pre-harvest control of the grain chinch bug. So the grain chinch bug is a pest of grasses and grains and is endemic to the Western Cape. During winter, the insect reproduces on its host plant. However, during summer, it enters a state of dormancy termed estivation. So this coincides with the harvesting of wheat and the harvesting and ripening of deciduous fruit in orchards. And this results in the mass migration of the grain chinch bugs from the wheat fields to the orchards, where the insects find shelter in the calyx, cavities of the calyx and the stem ends of pears. This results in the rejection of exported fruit, as the insect is a phytosanitary concern. So ideally, a holistic integrated pest management approach should be used to manage this insect. However, pre-harvest management and post-harvest management has proven difficult. There are currently no pre-harvest management options, and the only post-harvest management treatment that has been found to work is ethyl formate. So that brings us to the aim of this research, which was to investigate the use of entomopathogenic fungi and nematodes for the pre-harvest management of estivating grain chinch bugs. There were two objectives to achieve this aim. The first objective was to screen entomopathogenic fungi and nematode isolates for efficacy. The second objective was to conduct concentration dose-response bioassays with the selected isolates. So for the screening bioassays, 4 isolates were selected to test for the EPFs and EPNs. Estivating adult grain chinch bugs were placed in bioassay plates that was inoculated with entomopathogens. These plates were then placed in moisture chambers and incubated. For EPNs, mortality and infection was determined after 48, 72, and 96 hours. EPF results were taken after 7 days, after which overt mycosis was determined. So the EPN results revealed that Steinernema jaegelemens was the best performing isolate, reaching more than 70% mortality by infection. The local Heterobacterus bacteriophora was the second best isolate, and therefore these 2 isolates were selected for further experimentation. The EPF results revealed that none of the isolates were effective. They did not even reach 20% mortality by infection. There was also no statistical difference between isolates, so none of the isolates were selected for further experimentation. So the 2 selected EPN isolates were tested in the concentration dose-response bioassays using the same method as previously described, with the only difference being that 6 concentrations were tested for each isolate. The LC50, 90, and EC50 and 90 values were determined. So I'm just going to summarize this table. What it basically says is that Steinernema jaegelemens is more efficient and kills the grain chinch bugs at a much lower concentration compared to Heterobacterus bacteriophora, indicating its potential as a biological control agent. So to conclude, the EPFs was not effective against grain chinch bugs, estivating adults. However, Steinernema jaegelemens proved to be effective against grain chinch bug estivating adults under laboratory conditions. So high concentrations of Steinernema jaegelemens can be applied in commercial settings on hotspot areas and still be financially feasible while ensuring high efficacy. So the next step for me in regards to this research will be to conduct a field trial with formulated Steinernema jaegelemens. If this proves to be effective, it will be the first pre-harvest management option for this insect, according to literature. I would like to thank the following individuals and institutions, and thank you all.